Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today. Check if array pairs are divisible by k. In this problem, we are given an array of integers r of even length n and an integer k. We want to divide the array into exactly n by 2 pairs such that the sum of each pair is divisible by k, and we should return true if we can find a way to do that, or else we will return false. Then in example 1, for a given array and k equal to 5, we return true because we can form the pairs 1, 9, 2, 8, 3, 7, 4, 6 and 5, 10, where sum of all the pairs is actually divisible by 5. For example, 1 plus 9 modulo 5 is 0, 2 plus 8 modulo 5 is 0, and so on. So the main thing is we should form all the n by 2 pairs. For example, for n equal to 10, we formed 5 pairs and all the pairs sum should be divisible by k. Now, in terms of solution, one of the naive approach can be that we generate all possible pair of elements from the array and check if each pair sum is divisible by k by using, say, modulo operator. And if we find a configuration where all the pairs meet this condition, we will return true. Otherwise, we will return false. But this involves iterating through all the combination of pairs, which will result in time complexity of O of n square, which is highly inefficient. So how can we do better? But do we have to generate all the pairs to check if the pair sum is divisible by a number? And the answer is no. For that, let's look at modulo operator and the concept of remainder a bit closely. Suppose we are given two numbers a and b, and a modulo k is x and b modulo k is k minus x. Then we can say that actually a plus b modulo k is 0. That is, a plus b is divisible by k. And let's prove it. We can rewrite a plus b modulo k as a plus b modulo k modulo k. For example, 2 plus 1 modulo 5 is same as 2 plus 1, that is 3 modulo 5 modulo 5. It will stay 3 only. So then we can rewrite it as a modulo k plus b modulo k, and we can still keep the outside modulo k. So we know that a modulo k is x and b modulo k is k minus x. So we will get it as k, and that's why k modulo k will be equal to 0 itself. So now the problem becomes simple. We have to find out two numbers a and b in an array such that their sum is divisible by k. So for that, we have to find the pattern such that if a modulo k is x, then b modulo k should be k minus x. Then we can actually form one of the pairs. And if we find all such pairs, then we are good and we will return true in this case. So instead of dealing with each number pair, we have to deal with their remainder, and remainder of the number can fall between 0 and k minus 1. So how about we create a frequency array of size k, which acts like a bucket, storing frequency of all the remainders. So for the remainder x between 0 and k minus 1, we should have equal number of count of remainder k minus x. And if all the remainder pairs match, then we will return true. Otherwise, we will return false. So let's see this in action. In example 1, k is equal to 5. So let's create a bucket or array of size 5 representing the remainder 0 to 4. Now let's count the frequency of the remainders. 1 modulo 5 is 1. So we will increment the remainder frequency by 1 at index 1. 2 modulo 5 is 2. So we increment the frequency at index 2 to 1. 3 modulo 5 is 3. Frequency at index 3 becomes 1. 4 modulo 5 is 4. So frequency at index 4 becomes 1. 5 modulo 5 is 0. So we will increment the frequency of 0th index to 1. Then we see 10 modulo 5 is 0. So we increment the frequency of index 0 to 2. 6 modulo 5 is 1. So we increment the frequency at index 1 to 2. 7 modulo 5 is 2. So we increment the frequency at index 2 to 2. 8 modulo 5 is 3. So we increment the frequency at index 3 to 2. And finally 9 modulo 5 is 4. So we increment the frequency at index 4 to 2. And now we are done with all the elements. So now we have to find the matching pairs such that for each remainder x, we should have equal number of k minus x. So we start with remainder 1, for example, and remainder 1 occurs twice, once for element 1 and then for element 6. And now for x equal to 1, k minus x will be 4. So we should look at the frequency of remainder 4 so as to form the pairs that are divisible by k, that is 5 in this case. And we can see that frequency of remainder 1 and 4 actually match. So that means we can form two pairs such that their sum is divisible by 5. It doesn't matter what the actual numbers are. For example, here we can see that the numbers which leave remainder 4 are 4 and 9. So we can actually form the pairs like 1, 4 or 1 comma 9 or 6 comma 4 or 6 comma 9, and their pair sums are actually divisible by 5, and each pair sum is actually divisible by 5. So what matters is frequency of remainder k minus x, and x should match. Similarly, if x is 2, then k minus x is 3, and we can see that the frequencies again match. Let's verify this. So numbers with remainder 2 were 2 and 7, and numbers with remainder 3 were 3 and 8. So we can either form the pairs like 2 comma 3 or 2 comma 8 or 7 comma 3 or 7 comma 8, and each of the pair sum is actually divisible by 5. So this is another two pairs. And now we have to handle a special case when x is equal to 0. That is, our remainder is equal to 0. When x is equal to 0, k minus x will be equal to k, but that is a redundant remainder because k modulo k will be also equal to 0. So that's why we don't have it in the array. So because of that, we need to handle remainder 0 especially. We cannot compare it with other pairs in the array. Because we need pairs, whenever we see a number is divisible by k, we should find another number that is also divisible by k, and then only the sum will be divisible by k. So that means frequency of the remainder 0 should always be even. And here we can see that there are two numbers, that is 5 and 10, which are actually divisible by 5, and we can form a pair out of them as well. So we can form 4 pairs for remainders 1 to 4 and 1 pair for remainder 0. So we formed our 5 pairs, and hence we will return true in this case. Let's take a negative case as well. Let's take example 3. And here we can see that k is equal to 10. So we will create 10 buckets. Now we will start filling in the frequencies of the remainders. We can see that 1 modulo 10 is 1. So we will increment the frequency at index 1. Similarly, 2 modulo 10 is 2. So we will increment the frequency at index 2. And similarly, we will fill in the rest of the frequencies as well. Now we actually match the pairs. We can see that frequency of remainder 0 is even, which is a good sign because frequency of remainder 0 should always be even. Now for x equal to 1, we can see that k minus x will be 9, but there exists no number which has remainder 9. So because of that, we cannot form the pair at all. So hence in this case, we will return answer is false. Now let's jump into the code part. Let's create a frequency array to count the occurrences of all the remainders when the numbers are divided by k. Let's now fill in this remainder array by looping on the array, and remainder will be equal to number modulo k, but numbers can be negative as well. And in some programming languages, because of that, the modulo operator returns negative remainder. So to fix this, we can just add k to that number. So because of that, we will get a positive remainder. And now we can use the array indices to increment the frequency at the remainder index because indices are always positive. So now that we have filled in the remainder array, we can check if the remainder frequencies satisfies the pair condition. That is, frequencies for remainder x is equal to frequency for remainder k minus x. And here we are using iterator I. So frequency for remainder I is equal to frequency for remainder k minus I. We will start iterating from I equal to 1, and we will handle the I equal to 0 case later on. So if at any point frequency of I is not equal to frequency of k minus I, that means we cannot form the pair, and hence we will return false. And finally, we will check for remainder 0 elements. Count of such elements must be even to form the pair. That's it. So now let's run this code. Cool. Let's submit this code. Awesome. In terms of time complexity, it will be O of n plus k, where n is the number of elements in the array and k is the given input. And the reason for this is first we are looping on this numbers array that takes O of n time, and then we are looping on this frequency array that takes O of k time. And in terms of space complexity, it will be O of k because we are using this frequency array to store all the remainder frequencies. So that's it. I hope this video was useful to you. If it was, please like, share and subscribe. The code link is in the description below. If you have any questions or suggestions, please write them in the comment box. Thanks for watching. See you next time.